Here we have some pretty gnarly looking division problems. This first one is 1,568 divided by 49. That looks tough to me. How are we going to do this? Well, let's go ahead and set it up the way you would set up a normal division problem that you're doing by hand. The thing that you're dividing on the inside of the bracket, the thing you're dividing by on the outside. And then the first step is to look at these digits and see what you can, what can be divisible by 49. 1 isn't 15. Nope, that's smaller than 49. But 156, you could get some 49s out of that. So our first question is to think about what it would 156 divided by 49 be. What would that be? Well, one way to approach this is to just round these to easier numbers. So let's call this 150 and let's call this 50. And now it's pretty clear to me. I think there are 3 50s in 150. 150 divided by 50 would be 3. 150 is 50 plus 50 plus 50. So I'm guessing there are around 3 49s in 156. And if we're lucky, maybe exactly, I don't know. Let's try that by just multiplying. Let's do 49 times 3 and see what we get. So 3 times 9 is 27. And 3 times 4 is 12, 13, 14. Okay, so we got 147. It's not exactly 156, but it's the right number because it's less than 49 away from 156, and it's not over 156. That's what we're looking for down here. Whatever number we put up here, and this is going to be a 3, that's what we want to get when we multiply here, is something that's less than this number, but not less by more than this number. So 3 times 49 is 147. Now we subtract. So let's see, we'll have to borrow. And that just leaves a 9. The rest of that is zeros. And then we pull down the 8. All right, how many 49s in 98? Well, 49 is 1 less than 50. And this is 2 less than 100. So I think it's 2. Let's just double check. 49 times 2. 2 times 9 is 18. 2, oops, put the 1 up there. 2 times 4 is 8, 9. Yeah, so we'd put a 2 here. And when we multiply, we get 98. And when we subtract, we get 0, so there's no remainder. And our answer is 32. So maybe that wasn't quite as hard as it looked in the first place. Let's try another one to practice. This one looks pretty bad too, at least at first glance. But let's go ahead and set this up. So 29 is what we're dividing by, and we have 1,856. So 29 won't go into 1, won't go into 18, but it will go into 185. So that's our first thing to think about, 185 divided by 29. And let's just make these numbers easier. We'll round this to 180, and we'll round this up to 30. And this I can see already. We can cross off both those zeros, and it's 18 divided by 3, so that equals 6. So what this means is there's probably pretty close to 6 29s in 185. But let's go ahead and test that by multiplying it out. So 6 times 9 is 54. 6 times 2 is 12, plus 5 is 17. So we got 174. That looks pretty good. So I'm going to go ahead and put our 6 up here. And when we multiply 6 times 29, that's what we just did there, we get 174. And then when we subtract, 5 minus 4 is 1, 8 minus 7 is 1, 1 minus 1 is 0. So we got a difference of 11. As long as this number is not 29 or bigger, then we did it right. Then we bring down the 6. Okay. So our next question is, how many 29s are there in 116? And again, we can change the numbers here. So let's round this up to 120. Let's round this up to 30, see what we get. That would be 4. All right, that's a good guess. Let's check it by multiplying 29 times 4. 4 times 9 is 36. 4 times 2 is 8, 9, 10, 11. Yeah, perfect. So the 4 goes up here. When we multiply that by 29, we get 116. And then when we subtract, we get 0, which means there's no remainder. And this problem, the answer is 64. So that is a little bit of work with some long division.